Hello student, welcome to the online tutorial session. Today we will learn about three topics that are most crucial one and most important topic from this chapter. It is related to the operating system. So it is very important one. The topics are booting, spooling and the virtual memory. So what is booting? So the procedure of starting a computer by loading the basic components of the operating system into its main memory is known as booting. So I hope those are using computer, those are familiarly working with the computers are familiar with this term, the booting. Okay, so the word actually came from the term bootstrapping, okay, which is basically means the pulling the computer up by its own efforts. Okay, so what is actually the booting procedure involves, and we will learn it, and we also learn it about the different types of booting is available. It is not only that the starting of computer only known as booting, there are another type of booting is also available. So whatever steps I will which means the procedure I will describe is the general procedure of a booting of a system. Okay, so after starting the computer, the instruction register, that is IR, is automatically loaded with a predefined memory location from where the execution of instructions start. Okay, the primitive bootstrap program stored in the ROM and it is located at this memory location. Now next step is that the bootstrap programs perform a certain task when it is initiated. So one of its tasks is to run the diagnostic tests that check the states of a various component of the computer system. This is called as power on self test, or basically it is similarly known as a post test. Okay, so power on self test. So it consists of testing system bus, internal clock, video display card, RAM, keyboard and the disk drive. If the test is successful, the speaker emits a short beep. Okay, and now after that, if the post check is passed, it reads a simple block of code from the section of the hard disk called a boot sector. Okay, and load it into the main memory. The block of code stores the information regarding the location of the remaining portion of the bootstrap program, which is loaded the next. Okay, the final one, once the full bootstrap program is loaded, it can then locate the operating system kernel and the device. So driver, and loaded them into the memory to finally make the computer run. Okay, so depending upon the way the booting is actually taking place, we can have a two different type of booting. Okay, so one is known as cold booting and another is known as the warm booting. Okay, so the first process, that is a cold booting, the first process to carry out when a computer is turned on is initialize the microprocessor. Next, the power on self test, that is post, is carried out. It consists of testing the internal bus, the internal clock, video display card, RAM, keyboard, disk drives. Okay, so if the test is successful, the speaker emits a short beep. So this component of the operating systems are loaded into the main memory. So this whole procedure that I have just now described, this is actually a procedure for a cold booting. Okay, so whole procedure that I have just now spoken about it, that is a booting of a cold booting procedure. Okay, so next another type of booting is also available, that is known as a warm booting. Okay, so if for any reason the computer hangs while walking, that we are actually familiarly we are encountered this situation, so it needs to be restarted to make it functional. Okay, the computer can restart it by pressing Control Alt plus Del key simultaneously. Okay, so when this is done, the computer restarts by skipping the RAM text. Okay, so this kind of booting is known as a warm booting. Okay, So there are two type of booting. You just remember the warm booting is performed by pressing Control Alt plus Del key, because many of the time the options are coming, uh, and they will generally ask you what is the shortcut key for the warm booting, or generally they will give you the key combination, and they will in the MCQ, but they will tell you the which key combination is used for the warm booting. Okay, so this kind of a question comes from here. Or also they can directly ask you what is booting, or what is cold booting, or what is um, um, warm booting, or differentiate between cold booting and the warm booting. Okay, this type of questions coming from the topic booting. Okay, now next we will concentrate on the topic that is spooling. Okay, spooling is also known as the simultaneous peripheral operations online is a technique. Okay, so spooling is also known as a simultaneous simultaneous peripheral operation online. Okay, so this is a full form. Okay, is a technique used to solve the problem of speed mismatch between the processor and the peripheral devices. What are those peripheral devices? Like printers, keyboard, etc. The CPU works at much faster speed than the input output devices like keyboard and printer. So when a slow input output device is moving bytes to form a main memory, the bytes is actually, it is a unit, okay, of a to storing. In case of storage, we are storing in GB, bit and byte format. Okay, so it's a unit. Okay, so byte to form from to or from the main memory, the CPU remains idle for a large percentage of input output time, and cannot process the next data. So during this input operation, spooling reduces the CPU idle time by placing all the data that comes from a slow input device on a hard disk. Okay, so before it is loaded into the CPU for a processing. Similarly, after execution of CPU, the process data is first written too much as a faster speed in a magnetic state before, or it is output through a slow output device. So as interaction of the CPU with the high speed magnetic disk is much faster than that, so with a much more input device. So this is reduce the CPU idle time considerably. So whenever actually memory is passing from CPU to main memory, or main memory to CPU, it happens that it is the actually when it is coming from the input device, is the bit transmission rate is very slow, but in terms of going from main memory to CPU, or coming from CPU to main memory, and then from the output device, it is, this part is very fast. So this output device or input device cannot or match the speed of this data transmission. So that's why it is loaded into the intermediary state, and from that again it is according to the speed wise, again it is transmitted, or again it is transmitted to the CPU, or from the storage unit it will transfer to the output device. Okay, so now the next term is the virtual memory. Okay, so the to run a program, it is has to be loaded into the main memory. Program has to be loaded into main memory. So however, this can be done only when the sufficient main memory is free to load the entire process. So process may be kept on waiting before starting the execution till the sufficient memory is free. So whenever we are actually on an execution of a program or something, so entire process is we have to load it in the main memory. So if the main memory doesn't have the sufficient amount of free memory space, then the actually the process need to be wait, because whenever the that much amount of memory is free, then only we can load this process. So this delay of the process execution. Okay. So moreover, if the main memory size is smaller than the process size, the process can never be loaded in the main memory. So one also, the problem is that if the process size is more than the main memory size, then it will not have, never ever happen the having the sufficient amount of memory space, and then the program or the process will not executed. So in this type of situation, a memory management scheme is virtual memory overcome these problems. Okay, so it allows the execution of a processes even in case of insufficient free memory space present in the main memory. To do this, a portion of the memory of a high-speed secondary storage device like hard disks is used along with the main memory. The operating system uses this secondary memory as an additional memory area to the main memory. A special process called swapping is used to transfer the block of data between the secondary storage and the main memory as per the requirement. So what is actually a swapping technique? So using swapping technique, the operating system manages two memory areas such as a manner that user feels that they have access a single large main memory, but it is not. So whichever portion of a program process information is needed, that from the hard disk which is coming to the main memory. Okay, and whichever is not required from the main memory, it is again transferred to the hard disk. If it is something is required from the hard disk, it is again and coming to the main memory. So in this way, the whole process is still in the main memory. You don't have the sufficient space to run the particular program, but still you are running the program efficiently. This is the way, or this is a convenient way to execution of a process. This concept is known as a virtual memory concept. I hope the virtual memory concept is clear to you. Okay, thank you student. I'm ending my lecture over here.